Hello and welcome back to brainstemschool.com. Today we're going to talk about recursion. Recursion is a form of looping in which you write a function that calls itself. A very simple, although somewhat useless example would be counting down. In this function, you call countdown with any value of x, print that number to the screen, and then call countdown with one less. And this should be a pretty typical countdown. Can you spot the problem that's about to occur? Other than the fact that I can't spell my own function names. So we have a recursion error, maximum recursion depth exceeded. You might also have noticed a large number of negative values were output to the screen before we got into this recursive function call stack situation. So what's gone wrong? The problem is we never told it when to stop counting. So we need what's called a base case, which is typically done with an if structure. So you see we count down from 10 and we arrive at blast off when x equals 0. There is a problem, however, when we attempt to count down from a negative number. We'll reach that same situation where we blow the top, well, we're about to blow the top off of our function call stack, and Python cuts that short by giving us a maximum recursion depth exceeded error. The problem is it would be more appropriate to say when x is less than or equal to 0. That way, if we were to do a countdown of a negative number, it just goes straight to blast off and preserves the original functionality. Now you recall, I said this is kind of a useless example because you could very easily write a function that counts down. However, a more typical example would be the one to calculate Fibonacci numbers. Fibonacci numbers are defined as the sum of the previous two Fibonacci numbers. So in and of itself, it's a recursive process. So you can see Fibonacci of any x is the sum of the previous one and the previous one, the one that was 2 back, with two base cases where x equals 1 both times. I'm sorry, where the return value is 1 both times. So fib of 1 is 1, fib of 2 is 1, fib of 3 is 2, fib of 4 is 3, fib of 5 is 5, and so forth. Now this is a pretty good calculation because fib of 14 calls fib of 13 and fib of 12. Fib of 13 calls 12 and 11, fib of 12 calls 11 and 10, and so on and so forth. So you can see this uses quite a lot of memory pretty quickly. However, it looks like we are capable of doing all these numbers up to fib of 14. Anyhow, that is recursion in a nutshell. To be more specific, it's tail recursion. As you can see, the recursive function call is in the end of the function, and the base case is in the beginning of the function. And that's all we have for today. Head over to brainstemschool.com and check out the ebook. And of course, subscribe to the channel and have a great day. Happy coding.